Hello everyone. We are going to see today the concept of optical center in the lenses. So to see the clear concept in different type of lenses and its formula, let us see very carefully how it is given. We are knowing the lens is the part of two circles, two spheres intersect each other. Like here in the diagram, two-dimensional diagram is here given. Let us join the principal axis of it. Let this is the first surface of convex lens and it is the second surface. First surface, their center of curvature C1 lies on right hand side of the lens in a convex lens, and second center of curvature C2 lies on left hand side of it. Whereas in the concave lens, see it very carefully. Let us see concave lens here in the picture. Concave lens, see principal axis, this is circle, center of curvature C1 of first side in the left hand side, C2 on right hand side here in the lens. So this is the differences. We will see the concept of optical center by taking an example of convex lens and concave lens. So A, diagram A1A, convex lens, 1B, concave lens. So see here, first of all, in the convex lens, very carefully, we are going to see the phenomena of refraction by using this lens. So for phenomena of refraction, we are going to take first of all, this is incident ray. This is incident ray. This is the first surface of convex lens. So wherever the phenomena of refraction, if you want to see, at that point it is required. This is a normal required. Actually this incident rays is taken in the direction of normal. So we are going to take this as a normal, and at this point we are going to take incident ray here. This is the incident ray in this direction, and it is angle of incidence. We know that when a ray of light passes from rarer to denser medium, it bends towards the normal. So in bending towards normal means this ray of light comes in this direction. This is angle R. This R is less than angle I because it is entering from air to glass. Now see again, at the point 2, again phenomena of refraction takes place from glass to air. So again the normal is required here to draw. So this normal on second surface, it will begin from the center of curvature C2 in this way. Now these two normals are parallel to each other. So this angle is R. Automatically this angle of incidence become R. And one more thing important, this ray, it is known as refracted ray. Now, when it's come from glass lens to air, denser to rare, bends away from the normal in this direction. This is called emergent ray. Again this angle becomes I. Now see about the concept of optical center. See very carefully, this line is called principal axis. At this stage, the point where principal axis and refracted ray intersect. See very carefully, point at which refracted ray and principal axis intersect. Here this point is C. Point at which this both intersect is called optical center. So point C is this then called optical center. Let us take the two things very carefully. It is the second side. Let its pole P2 is on this side, P1 is in this side. Then it is very important to see that distance CP1 and CP2, the ratio of CP1 to CP2 divides here on the ratio of their radii of curvature. The same thing, the same ratio holds for here in case of concave lens also. So to see here in the concave lens, let us see very carefully for the diagram. So for the diagram of it, see very carefully here in this case. Let us take a normal from the first side of the center of a curvature. We are going to take, it is incident ray. Incident RAY, incident ray. Normal, this is angle of incidence, right? When ray of light, this is moving from rare medium to denser medium, it bends towards the normal angle of incidence. So bending towards normal is, see very carefully here, this phenomena of refraction takes place here. This is known as refracted ray. Again, at this point again refraction takes place. From here again draw normal, then moving R and I, moving away from the normal angle of incidence. See, this is principal axis. So principal axis and refracted ray intersect at optical center C. This is the first side and center of curvature. So P1 will be at this side and P2 will be on another side. So the ratio of CP1 by CP2 is equal to value of their radii of curvature. What is the radii of curvature? See very carefully this C. It is a C2. So C2 is, this is center. This distance is R2 and this distance is R1 here in this case. And here for first side C1, here R1 is from here to here, center of curvature. R1 and R2 is called from this side C here, and it is center of curvature. This is R2 distance from here to here. Since we know that the lenses is of three type, the first type of that is a biconvex lens or biconcave lens. So in biconvex and biconcave, if we take this example for concave and convex lens, so let us see very carefully for the concept of optical center. Let this is convex lens and principal axis. Concave lens, this is the first side, second side. First side, their center of curvature C1 is in this side. Second, its center of curvature C2 is on left hand side. Clear? If both are bi equals, if radii of curvature here in this case R1 is equal to R2 in case of biconvex lens, then see how it takes place. Let it is incident ray. First of all, see this is incident ray. Here see very carefully, this incident ray is just passing through the and without undeviated here in this case. This is the optical center. In that condition, this point is called P1, P2, and the formula which hold here CP1 by CP2, it is equal to R1 by R2. Since R1 and R2 is equal, then it means that it is R by R is equal to 1. This implies that CP1 is equal to CP2. Here in this case, if CP1, this distance, see here in the diagram carefully, this distance is equal to here, then optical center is found at midpoint on it. Optical center at this condition, optical center at mid point of P1 P2, because CP1 is equal to CP2. Same situations occur here in case of concave lens also. Let us consider a concave lens. Of equal radii of curvature. First side of concave lens, second side, its center of curvature C1 and C2 is according to this here diagram. And when we and let this is a point, dotted line divides. If any incident ray we take, here in this case, it is just like this. We are knowing it is, the points are here, P1, P2, optical center is at point C, CP1 by CP2 is R1 by R2. Since R1 and R2 is equal here in both cases, here see in the diagram, it is R1 and it is R2. Both are equal, ratio 1, CP1 is equal to CP2. Then this observation is obtained here. Optical center is found at midpoint of P1 and P2. So it is clear that optical center depends upon the ratio of radii of curvature. Now we are going to see the two opposition optical center at two different type of the lens, that is plano-convex lens, plane type lens, and concavo-convex type lens. So let us see. Now see the position of optical center in plano-convex lens and plano-concave lens. In plano-convex lens, very carefully. First side plane, second side convex. Plane, convex, plane, convex. Plane on left hand side, this is. Very carefully see here. Plane means R1, radii of curvature is infinite of plane. And let R2 is equal to R. See the diagram here, how the ray will go. Incident ray, refracted ray, emergent ray. Emergent ray here. The point P1 is here, P2 is here. Center of curvature, optical center, C just lies here. Principal axis and this is refracted ray. It is principal axis. So in both, here in this case, point C and P2 coincide. This implies that CP2 is equal to 0. Same situations occur here in case of concave lens. Let us see this concave lens. Situation: first side, second side, principal axis. First side plane radii of curvature is infinite. Second side, their center of curvature P1 pole, P2 pole. First side, second side, this is radii of curvature, R2 is equal to R here. Let us see the ray diagram here. Refracted ray, then emergent ray. Here see again, principal axis and refractive index coincide each other. This point is also hold here, CP2 is a 0 because C and P2 is a coincide. Then see what formula speaks. What is the formula? CP1 by CP2 is equal to R1 by R2. See here in the formula, CP1 by Cp2 is equal to R1 by R2. Cp1 by Cp2 is a 0 is equal to R1 is infinite by R. Or this implies that Cp2 is equal to 0. This is the concept. If we write here Cp2 and it is infinite, so Cp2 is equal to 0 here in this case. Now position of optical center in case of concavo-convex lens and convexo-concave lens. It is totally different from the beginning. See the diagram of concavo-convex. This is the first side, second side. First side is concave, second side is a convex. This is first side. Let us see the principal axis very carefully. Principal axis, center of curvature for first surface C1 and it is C2. Both are lies in same side. P1, P2. First of all, see the ray diagram. Incident ray, refracted ray, emergent ray. It is the diagram. Now see very carefully. This is the refracted ray. Here refracted ray, this is the emergent ray, it is incident ray. Here refracted ray and optical center, principal axis do not coincide. See very carefully. Refracted ray and principal axis do not coincide. Now let us see what happened here in case of the second convexo-concave lens. Convexo. See the convexo-concave lens. First side convex, second side concave. Convexo-concave. Clear? Let us see the principal axis here in this case. Here see first center of curvature C1, second C2 of the both center of curvature. First of all, see the phenomena of refraction through it. Incident ray, refracted ray, and finally emergent ray. In this case, this is here in this refracted ray. See in both the diagram, principal axis is here. It is the axis. Here also the same situation holds. What is the same situation? Refracted ray and principal axis do not coincide. Right? If it is do not coincide, let us see the normal here in both cases. Here, normal. Both are not coincide. each other, neither in the first type of lens, not on the second type of lens. Then let us see what formula speaks. Cp1 by Cp2 is equal to R1 by R2. Then where will be the exact position of optical center? So to see this, see the refracted ray. Refracted ray proceed forward. It seems to meet at this point, optical center. And now see in this case, proceed, see. So here in both places, optical center outside the lens, outside the lens. So you see, summarize the whole calculation here, whole discussion here. What is this? In the beginning, optical center here in the lenses. The definition is clear. Optical center is a point at which the refracted ray and principal axis is intersect. One thing is required, either intersect or appear to intersect. By relation Cp1 by Cp2 is equal to R1 by R2, and it is just at midpoint when it is a biconvex or biconcave. But see here in this case, when it is plano-convex lens, center of curvature, this optical center is lies on the surface in both cases, whereas in concavo-convex lens and convexo-concave lens, it does not lies inside the lens. It is seems to appear in the principal axis outside the lens. So this is for the whole topic. Thank you and have a nice day to all.